Despite being a top 10 crypto, there is no chain more confusing than PolkaDot. With its cross-chain interoperability, its unique take on governance, and its many roles. So stick around and let's talk about it. Hey guys, I'm Sprag, and there's a chain that most people will have heard of, but very few understand. And really, that's not surprising when you consider just how complex PolkaDot actually is. There are so many components that go into making the PolkaDot chain work, and the fact that PolkaDot doesn't aim just to be a single chain, but a chain of chains, allowing both public and private chains to be built on top of it and communicate with each other. It's a very complicated project. But before we get into the crux of how PolkaDot works, I am not a financial advisor. This video is purely educational, and if you enjoy the content, please consider subscribing. No discussion about PolkaDot can start though without talking about its founders. Gavin Wood, a name some of you might recognize, was the initial author of the PolkaDot white paper. He was also the co-founder of Ethereum and the person that created Solidity, the language that most people use for writing smart contracts on the Ethereum chain. Alongside him are Robert Habermeyer, a Thiel fellow with an extensive background in Rust, which allows them to harness the language's many benefits to get the most performance out of the chain. And Peter Sabin, the current technology officer for Web3, who has an extensive background in mesh networks, machine learning, and many other areas of software and business development. Whereas a lot of chains will use Python, which is a lower bar of entry but less performant language, PolkaDot instead uses Rust, which allows it to benefit from the many improvements that the language has made over the years in terms of performance. This, and the fact that its founders are all very well known and established programmers, gives PolkaDot a very strong foundation to build off of. Now, while a lot of people consider PolkaDot to potentially be an Ethereum competitor or an Ethereum killer, in reality, PolkaDot actually aims to work alongside Ethereum. And while it does allow smart contracts to be created on top of its parachains, its main goal is actually to allow its users to create chains on top of its relay chain. The relay chain and parachains are something we will cover further in this video, but for now all you need to know is that parachains are a way for users to create either public permissionless blockchains or data structures, or private and permissioned data structures on top of the PolkaDot network. This means, for example, there could be a private chain built for keeping track of students' academic records, while there could be a public chain that uses the private chain to validate academic achievements. This is an extremely powerful concept because not only does it let anyone come on and create a chain, it allows organizations to create public chains, but give them external access to any applications that need it. There is, however, a problem with all of this though, and one that I will cover in more detail further along in the video. But the complexity of PolkaDot is extremely high. I have previously created my own proof of stake chain in Rust just as a learning exercise, and I've dabbled in creating smart contracts on other chains before, but learning about PolkaDot to write this script was an extremely steep learning curve, and it's going to put off developers that aren't extremely serious about developing on PolkaDot. But hopefully in this video I can demystify some of the areas of PolkaDot that seem to cause people problems when learning about it, and that leads us into our first topic, the DOT token. The DOT token serves four major functions: governance, staking, bonding, and paying certain transaction fees. Governance in regards to a blockchain is how decisions that affect the protocol are made. This is a decentralization problem that a lot of chains have a lot of different methods for solving. This is because the majority of chains are actually programmed by an organization or a collection of individuals. And what this means is that if there's no governance on the chain and the organization or individuals have a full and authoritative control over what changes to the protocol are going to be made, this means that you could argue the case that it's no longer a decentralized chain. Because if one governing body is making all of the decisions for the chain, then in some regards it is very centralized. Some chains will handle this by having unbiased but trusted members handling the governance. For example, Ripple has its Ripple Net, which splits its governance members into two groups. Users on the Ripple network can apply to become part of their regional committee, which is a select group of individuals that handle some of the governance voting. And then the other half of the governance is handled by the Ripple Net Committee, which is a group of financial institutions selected by Ripple to make sure that all protocol proposals are in line with regulatory requirements. But this does raise the issue that not everyone on the Ripple network can take part in governance. Only those selected by the Ripple Foundation can. Most chains will have their protocol rules hard-coded into the chain. This means that when something happens to deviate the code hard enough away from the protocol rules, a hard fork will occur. A hard fork just being where the chain has now taken a split and changed the initial rules that it was created on. An example of this is the recent Berlin hard fork that Ethereum had, which was where all of the nodes voted in majority for the hard fork to go ahead. Most of these methods, however, share a commonality, and that's the exclusivity of governance. That means that if you want to be part of the governance process, you either need to run a node, be selected as a committee member, or be a miner, which isn't accessible to every single participant on a network. PolkaDot, however, gives the power to any DOT holder, and this includes voting on governance changes for major things on the protocol. And simply just by holding DOT, you can become part of the governance protocol. There are 3 roles when it comes to DOT's governance. There is being a holder, part of the council, or part of the technical committee. Holders simply use their DOT to vote for proposals. On the other hand, council members are voted for by the holders and can propose new changes to the protocol. Their votes are also counted for slightly higher than the holders are. And then the third group is the technical committee. These are the people who are currently actively working on PolkaDot, and therefore they are allowed to propose emergency changes to the protocol to sort out issues. The second use for the DOT token is staking, which again, PolkaDot does it slightly differently to ensure decentralization on its network. PolkaDot uses nominated proof of stake. In nominated proof of stake, there are 2 roles, nominators and validators. To become a validator, one must run a node and start earning reputation by doing things like keeping the node's uptime consistent. However, there is a cap of number of validators, which started at 1,000 and has slowly grown over time. On the flip side, there's the far more accessible nominator, which is where you can use your DOT to vote for up to 16 validators. However, if the validator that you have voted for misbehaves, you will have your stake slashed. Like in some other proof of stake systems, tokens staked on the PolkaDot chain will be bonded and can't be withdrawn for 28 days. However, one area that PolkaDot differs massively from a lot of other proof of stake systems is that PolkaDot doesn't pay its pools out based on how much stake they have. Instead, it will pay all pools equally to ensure that people will move to other pools to get a fairer distribution. Because of the fact that each validator's pool will get paid the same amount in reward as other pools, this means that how much of a percentage you have in terms of the total stake of your pool will actually affect how much you get paid out. What this means is that for smaller stakers, it's actually more beneficial for them to move to a lower staked pool and not just go into the largest pool they can find. A second mechanism that's in place to make sure that decentralization is somewhat enforced is the concept of validators being oversubscribed. What this means is that a validator has more than 128 nominators voting for it. And in this event, when the reward is paid out, only the highest 128 stakers in that pool will receive a reward, with anyone staking less than those 128 receiving nothing, encouraging them to go and find a pool where they will receive a reward. As I mentioned, if you want to withdraw your stake from a validator, you have to wait 28 days or 7 days on Kusama for those tokens to become unbonded, because bonding is how parachains are deployed upon the relay chain. And then DOT's final use, transaction fees. But again, PolkaDot takes a fairly different stance to those that other chains that allow infrastructure to be built on top of them take. For example, Stellar requires all fees to be paid in XLM. Ethereum requires all fees to be paid in Ethereum, and Binance Smart Chain requires all fees to be paid in BNB. The difference is that in PolkaDot, the parachains actually decide how the fees are paid. However, there is one time when DOT will always be used as the transaction fee, and this is when any transactions are occurring between parachains. Anytime the relay chain is used, then a transaction fee of DOT is required. Which brings us to the reason that PolkaDot is such an interesting project. The chain, how it works, and what Grandpa and Babe have to do with achieving consensus. Beneath everything is the relay chain. This is the chain on which every parachain is built, and also where transactions are finalized. Unlike many other chains, PolkaDot has separated the act of validating transactions and creating blocks, which we'll cover in a second. But what this means is that they can achieve a reported 1,000 transactions per second at the moment, but a theoretical transactions per second of 1,000,000. Built on top of this core layer, we have the parachains. These are custom data structures that have their own tokens and use the relay chain to process their transactions. But note how I said custom data structures and not custom blockchains. This is because there's nothing that explicitly states that a parachain has to be a blockchain, and they can in fact take any structure or form. Also, just a quick fun fact, the level of customization afforded to those creating parachains is so big that even though consensus is reached by the relay chain, they could, in theory, implement their own staking mechanism. This brings us to the next role in the PolkaDot workforce. The Collaters. It's the collator of a parachain's job to collect transactions that happen on a parachain and build blocks for the relay chain. It's also the collator's job to run a full node and retain all required information needed for the running of a parachain. This is how parachains can finalize transactions without having their own consensus mechanisms. But Parity weren't happy just creating chains on chains. They also wanted to give users the ability to integrate into existing chains too. Currently in development are bridges. Bridges will give users interoperability between chains such as Ethereum, Bitcoin, Cosmos, or EOS, which means that someday we could actually see full interoperability between all known chains working via the relay chain of PolkaDot. And now I'm finally going to answer the question, what do an old man and a pig have to do with reaching consensus? Grandpa, or Ghost-Based Recursive Ancestor Deriving Prefix Agreement, is the finality mechanism for the relay chain. Like a lot of other consensus algorithms, Grandpa can reach finality as long as 2/3 of the network are behaving correctly. However, unlike various other FBA implementations, Grandpa is actually asynchronous, which means that as long as just 20% of the network are in sync, finality can still be reached. When at least 2/3 of the network agree on a specific chain containing a specific block, that block and all blocks preceding it are finalized. This method of finalizing an entire chain instead of just a single block significantly increases the speed at which finality can be reached. And under optimal conditions, this should be able to reach finality almost instantly. However, in periods of poor network performance, once the issues have been corrected, in theory, millions of transactions could be processed simultaneously. BABE, or Blind Assignment for Blockchain Extension, is how blocks are produced on the relay chain. This performs in a similar way to Ouroboros, where a lottery is played and the next block validator is chosen from the winner. However, this does mean that a block could have multiple validators, or also no validators. This is why there is no fixed block time on the PolkaDot chain, as the lottery would have to be run again in the event that no validator was chosen. So if you manage to digest all of this information, you're probably thinking, well, this is the #1 everything killer. It can do it all. Why aren't I only investing in this? But there's the one major problem that I mentioned earlier. It is too complex for most use cases. I have tried my best to fit as much as I can into this video while trying to balance between complexity and time taken to explain it. I could easily double the length of this video and I would still be cutting stuff out. For example, fishermen. And the thing is, when the bar for learning crypto in the first place and understanding blockchains is so high, adding this amount of complexity on top of it is going to turn a lot of people off trying to develop on the PolkaDot chain and instead drive them to use easier solutions such as ERC20 tokens. Because building a smart contract on Ethereum is so much easier than trying to wrap your head around parachains, the relay chain, and just how to get even started on the PolkaDot ecosystem. The second issue with PolkaDot is the inflation of the DOT token. Initially, the supply was capped at 10 million DOT. However, to encourage network participation, this was changed to be uncapped and a rate of inflation was imposed. And now you're probably going to want to brace yourself before I tell you what this rate of inflation is. Are you ready? It's 10%. Yep, you heard that right. A 10% inflation rate on the DOT token. This is because there are so many roles on the PolkaDot network that it can't really afford its DOT holders to do just that, hold. Instead, it requires those holders to actively partake in the network. This also means that at times when network participation is at its lowest, the inflation could even be as high as 100%. This means that for those of you who just want to buy a coin, stick it on a cold storage device, and then forget about it for 10 years, probably want to think twice about investing in the DOT token, because realistically, it's just going to devalue over time unless you are participating in the network. However, DOT is an extremely promising project, and as long as you know what you're getting into when you invest in it, there's not really much I can say wrong about it. The team is solid, the concept is phenomenal, and their push to try and bring some unity into the crypto space gives it an extreme edge. This will definitely be a token that I keep my eye on, and probably one that I'm going to learn more on a technical level just to bolster my knowledge a little bit. So I hope that you enjoyed the video. If you did, this took so much research and so much script writing to try and fit as much as I could into a time frame that was suitable for a YouTube video. So if you did enjoy it, please do hit the like button, and if you enjoy my content, please subscribe. Thanks, bye.